I'm Tatyana.
I'm Kyra.
And I'm Kamaria.
And this is our solubility versus temperature video.
Solubility is the property of a solid, liquid, or gaseous chemical substance called solute to dissolve in a solid, liquid, or gaseous solvent to form a solution of the solute in the solvent. Basically, it is a substance's capability to be dissolved. You could also say that it is a measure of how much or how easily a solute can be dissolved into a solvent. Now it's time to conduct our experiment demonstrating solubility. This specific experiment demonstrates the solubility of sugar into water at different temperatures. Here, we have 3 different bowls of sugar. We've added food coloring in order to differentiate between the 3 temperatures. The blue sugar will be added to the cold water, the yellow sugar will be added to the lukewarm water, and lastly, the red sugar will be added to the boiling water. Before we begin, it is important that you know 2 key terms that will be prevalent in our experiment. The solute is the substance that dissolves. In this case, it will be the sugar. The solvent is the substance that the solute dissolves into. In this case, it will be the water. Together, the solute and the solvent make up a solution. Now I'm going to start off by taking my cup out of the freezer. It's been in there for quite a while. I'm just going to wipe off the sides of the cup to make it a little bit easier for you to see the solution dissolve. And then I'm going to take my blue sugar and pour it into the cup. If you look really close, you can see that it's going to take a while for the sugar to dissolve. The sugar is moving around in the cup, and there's still some sugar left at the bottom if you look closely. I'm going to measure the temperature of my water. Wow, that's cold. Next, we'll see how the sugar dissolves into lukewarm water. If you pay attention, you can see that it doesn't take nearly as much time for the sugar to dissolve. There's still some sugar left over at the bottom of the cup, but not as much. Now we'll take the temperature, and the water has been sitting out, so it's at room temperature. Next, we have the boiling water, and Kyra is just prepping that by pouring the water out into the cup that has been boiling on the stove. Now Kyra is going to take her red sugar and she's going to pour it into the cup with her boiling water. If you look closely, you'll notice that the sugar dissolves much quicker. There's also no sugar left at the bottom of the cup like the other 2. Now Kyra is going to take the temperature of the water. Wow, that's hot. Okay, so now we're showing you how to draw a solubility graph. And a solubility graph is exactly what you think it is. It graphs solubility. Our x-axis, which is our horizontal axis, is labeled temperature in degrees Fahrenheit, and our y-axis, which is our vertical axis, is going to be labeled solubility rate. Now we're just putting our numbers down for temperature. So now we have our green line plotted, and we're going to draw that again just a little bit better. That line represents the rate of solubility. As you can see, that is a positive slope, meaning that as the solubility rate increases, the temperature increases. This basically means that when the temperature gets higher, involving sugar and water of course, that the rate of solubility will increase. The cold water has a lower solubility rate. The medium temperatured water has a slightly higher solubility rate, and the hot water has a much higher rate of solubility. Well, this makes sense, doesn't it? I mean, you remember the sugar-water experiment. When we put it into the cold water, it took a little bit longer to dissolve. The medium temperatured water, a little bit less time, and the hot water dissolved almost immediately with no leftover sugar. You're probably asking why? What is this magic power that makes life the way it is? Well, not to fret, my friends. I have an answer, and it is called the kinetic theory of matter. You should probably write this down. The kinetic theory of matter states that matter is composed of a large number of small particles, individual atoms or molecules, that are in constant motion. So, the higher the kinetic energy of a molecule, the more it vibrates. And the more it vibrates, the more space in between the molecules. So that allows for the molecules of the other substance to get in between those spaces more easily and to combine with the other substance more easily, thus having a higher rate of solubility. That's why when we saw the red water or the hot water, we noticed that it mixed a whole lot faster and there wasn't really any leftover sugar. And that's mainly because the rate of solubility was so high. Because the hotter the water was, the faster the particles were moving, the more far apart they were, and the more room there was for sugar particles to get in between the molecules in the water. Saturated solution. A solution that contains the maximum amount of dissolved solute. Unsaturated solution. A solution that does not contain the maximum amount of dissolved solute. Supersaturated solution. A solution that contains more than the maximum amount of dissolved solute. Kinetic energy. The energy an object or molecule possesses due to its motion. Solubility graph. A graphic representation of the variation with changing temperature of the solubility of a substance in a solvent. a higher rate of solubility.